Hi, in section 7.3, we're going to be looking at the unit circle. So the unit circle is going to be really helpful here moving on forward until like the rest of the semester. So this is really important. And I will provide everyone with the unit circle on Canvas. So unit circle is a circle centered at the origin with radius 1. That's why they call it the unit circle, because the radius is 1 unit. The equation of the unit circle is x squared plus y squared is equal to 1. That's the equation of a circle with radius 1 centered at the origin. In a unit circle, the length of the intercepted arc is equal to the radius of the central angle t. Okay, so they give you a picture here, the 4 quadrants, and you have a point that's on the circle, x, y. So as you can see, the x value is going to be the cosine because it's adjacent over hypotenuse, and since the hypotenuse is 1, this side is, the x coordinate is simply going to be cosine. The y coordinate will simply be sine, because sine is opposite over hypotenuse, which is sine over 1. So it's just going to be sine. Okay, let's keep going. So the cosine function is the x coordinate of the point. So you have this identity, cosine of t is equal to x, and the sine function is the y coordinate, which gives you this identity, y is equal to sine of t. Therefore, the coordinates of any point on the unit circle can be written as x comma y, which is equivalent to saying cosine of t comma sine of t, because cosine is the x coordinate and sine is the y coordinate. Okay, let's continue here. So the first exercise says a point P on the unit circle corresponding to an angle T has coordinates negative radical 2 over 2, comma radical 2 over 2. Find the cosine and the sine functions. Well, recall that cosine of T is simply the x coordinate. So it's going to be negative radical 2 over 2. And then sine of T is equal to the y coordinate, which is square root of 2 over 2. So that is the answer. Okay, let's move on to the next page. All right, because x is equal to cosine and y is equal to sine of t, substituting these into the equation, the circle equation, x squared plus y squared equals 1, yields the Pythagorean identity. So this is the Pythagorean identity, which is going to be very useful for us moving forward. So if you substitute cosine into x and sine into y, you get this equation, which is going to be cosine squared plus sine squared is equal to 1. Okay? All right, so let's apply that for this next exercise. It says, if sine is equal to 3 over 7 and t is in the second quadrant, find cosine. Okay, well, there are 2 ways to do this. Let's do it using the Pythagorean identity. So if you substitute 3/7 into sine, then you can solve for cosine. So let's do that. Okay, so we have cosine squared plus sine squared. Instead of sine, we're going to replace sine. We're going to substitute 3/7 in for sine. Don't forget the square, equals 1. So all I did was I replaced sine with 3/7. And I'm not forgetting the square. Okay, so if I square this fraction, 3/7 squared is going to be 9 over 49. So now we have cosine of t squared plus 9 over 49 is equal to 1. Now we can subtract 9 over 49 to both sides. Okay. Whenever you have 1 minus a fraction, it's always a good idea to rewrite the 1 as a fraction with the same denominator as the fraction that you're subtracting from. So since we're subtracting 9 over 49, you can call 1 is the same thing as 49 over 49. So now it's much easier to subtract 49 over 49 minus 9 over 49 because we converted 1 into a fraction. So now we can subtract these 2 fractions because they have a common denominator, and we end up with 40 over 49. So now we have cosine squared. So let me just draw a line here. Okay, cosine squared of t is equal to 40 over 49. And now if we take the square root of both sides, we are going to end up with cosine is equal to plus or minus square root of 40 over 7, because the square root of 49 is 7. So now we have to determine whether it's positive or negative. The plus minus comes from the square root of both sides of an equation. That always introduces the plus minus. However, we are in the second quadrant, so let's see how we can use that information to determine whether or not whether we should use the positive or the negative value. So in the second quadrant, notice that in the second quadrant we have negative, positive, right? The x coordinate is negative and the y coordinate is positive in the second quadrant. Since we're solving for cosine, cosine is the x coordinate, cosine is negative in the second quadrant. Therefore, this should be a minus. So our final answer should be cosine of t is equal to negative 40 over 7. Once again, the reason why it's negative and not positive is because they tell us that t is in the second quadrant. In the second quadrant, we have negative, positive, and cosine is negative. Therefore, cosine must be a negative value. Okay, so that is the final answer. Okay, let's move on. Okay, so now they're going to give us some more information regarding the special triangles, which we talked about in the previous section, 30, 60, 90, 45, 45, 90 triangles. So for 30 degrees, if you look at this diagram down below, 30 degrees is here. This is your 30-degree angle. Notice that the coordinates are radical 3 over 2, comma 1/2. They give us that info here. For 45 degrees, or pi over 4, that would be this angle. Here are the coordinates, so we can write those in as square root of 2 over 2, square root of 2 over 2. And over time, you're going to really come to memorize these because you're going to see it so often when you're looking at the unit circle. These are the coordinates that you're gonna see quite frequently. For 60 degrees, that would be over here, which is equivalent to pi over 3. The coordinates are 1/2 comma radical 3 over 2. Okay, let's keep moving on. So now they're going to talk about reference angles. So a reference angle is an acute angle. So let's highlight that. It's going to be an acute angle. The notation they use is T prime. Okay, and remember that acute means that the angle must be between 0 and 90 degrees. Okay, that's what it means to be acute. The angle must be between 0 and 90 degrees. Formed by the terminal side of the angle T and the terminal side, and the x-axis is what I meant to say. So it's the angle formed by the terminal side of the angle and the x-axis. That's how you determine what the reference angle is. So let's look at some examples of that. So there are different cases. If you're in quadrant 1, then the reference angle is just the angle itself. So in quadrant 1, because quadrant 1 are all acute angles, T, the reference angle would just equal to T, whatever the angle is. In quadrant 2, you have to subtract the angle from 180. In quadrant 3, you would have to subtract you would have to reverse it. Instead of 180 minus T, it would be T minus 180. In radians, that would be T minus pi, because 180 degrees is equivalent to pi. And finally, if you're in the fourth quadrant, you're going to do 2 pi minus T, or equivalently 360 degrees minus T. Okay, so it's actually a lot easier to just draw the picture. So let's look at the first example. The angle 225 is in quadrant 3. So let's draw that angle. 225 is going to start here, and it's going to go all the way over here. That's 225 degrees. All right, so we're looking for the reference angle. Recall, the reference angle is the angle formed by the terminal side, which is here, and the x-axis, which is here, and it has to be acute. So this angle here is our reference angle. Once again, it's the angle formed by the terminal side of 225 and the x-axis, and it always should be acute. So here it is. So as you can see, this is 225 here, and this is 180. So what you would do is you subtract 180 from 225. So let's write that. So our reference angle, T prime, is going to be, it's always going to be the bigger angle minus the smaller angle. 225 obviously is bigger than 180. So when you subtract, you should end up with 45 degrees. Okay, so that's your reference angle. All right, let's try another example. All right, this time they give us the angle in radian form, but it's the same exact process. So let's go ahead and draw our coordinate plane. Okay, the angle 5/3 pi, if you were to draw that, that's going to be in quadrant number 4. It's going to be way over here, and here's where you start, the initial side, and you're going to go all the way around. That's 5/3 pi here. And you can see on the unit circle that I give you that you can use your unit circles to locate the angles 5/3 pi on the unit circle. Okay, so let's find the reference angle. Remember, the reference angle is the angle formed by the terminal side, which is here, and the x-axis, which is here. So this is our acute angle. That is the reference angle that we're looking for. Okay, so notice that this is 2 pi, which is 360 degrees. And in order to find this angle here, T prime, you have to take the bigger minus the smaller. So 2 pi minus 5/3 pi. So let's write that out. 2 pi minus 5/3 pi. We do need a common denominator, which is going to be 3. So put a 1 over the 2 pi, multiply by 3, and you should get 6 pi minus 5 pi, which is equal to 1 pi over 3. And that is the final answer there. Okay, so let's keep moving down our notes. So using reference angles to evaluate trig functions. Okay, so this is going to be helpful when you're trying to evaluate trig functions of certain angles. So you can use reference angles. So let's go ahead and see how they want us to do this. So first things first, I recommend that you first draw the angle in standard position. So let's draw the coordinate, the coordinate plane, and then let's draw the angle 150 degrees. So if you draw the angle 150, that would be over here in the second quadrant. Okay, that's 150. Okay. You can use your unit circles. Your unit circle will tell you the coordinates of that angle. And for 150, the coordinates are negative radical 3 over 2, comma, 1/2. All right, so they're asking us to find the cosine and the sine. So in this case, you would simply just cosine. You just have to remember that cosine is the x-coordinate and sine is the y-coordinate. So our final answer is just going to be cosine of 150 degrees is equal to the x-coordinate, which is negative radical 3 over 2, as you can see here from your unit circle. And sine of 150 degrees is going to be the y-coordinate, which as you can see is 1/2. So that's how the unit circle is super helpful. It's going to allow you to evaluate trig functions of different angles. Okay, let's try another one. This time the angle is given to us in radian form, but same thing, you just use your unit circle. So it says find the coordinates of the point on the unit circle at an angle of 7/6 pi. Okay, so if you draw the coordinate plane, oops, that's not what I wanted to do. This is what I wanted to do. Coordinate plane 7/6 pi on your unit circles will be over here in quadrant number 3. So this is the angle 7/6 pi. All right, and if you look at the coordinates of that angle, you will see that they are negative radical 3 over 2, comma, negative 1/2. And they're asking us to find the points. So the point would be x, comma, y. So x comma y, x is simply, the x coordinate would be negative radical 3 over 2, and then the y coordinate is negative 1/2. So that is all we had to do with that one. And that completes this section.